So in this video, we're going to look at 10.4, which is going to be our measures of central tendency and variation. Specifically, we're just going to focus on the center of the data versus the spread. That'll come later, the measures of center of the data. And so we have three of them, mean, median, mode. You guys are probably very common with them. The mean is going to be your average. Mode is going to be the number that occurs most often. And then the median is going to be the center. So all three of those give you a picture of the center of the data. And so our definition of arithmetic mean, AM, you'll see it abbreviated sometimes, or we'll use X bar later on. That's going to be our average. You can see the big fancy math definition, but I went ahead and summarized it in that highlighted part that said you're going to add up all the data and then divide by the number of things you added. And so let's use those in this example. Use the mean to determine which class scored better on their test, Miss Roberts, Miss Kitts, or Miss Moore's class. So to find the mean, or X bar, we're going to add up all the data points. 85 plus 97 plus 54 plus 63 plus 91. And then divide by the number of points I had. 1, 2, 3, 4, 5. Make sure when you type this into your calculator, you do the top and then do the bottom. Don't try and type it in one go. If you do type it in one go, you have to put parentheses around the numerator. But I like to take it in two steps. So I'm going to add up the numerator, and I get 390. And then divide by 5 is going to give me an average of 78% on their test. I'm going to do the same thing with Miss Kitts. Add up all the numbers. And then divide by the number of tests, which she had 6. So when I add up the top, I get 501 divided by 6 is going to give me an average of 83.5%. And then lastly, Miss Moore, I'm going to add up all those numbers and then divide by 4. And so when I add up the top, I get 293 divided by 4 is going to give me a class average of 73.25. If it doesn't say, just leave all the decimal places. If it does say to round to the nearest whole percent or nearest tenth of a percent, then round accordingly. My question, though, said use the mean to determine which class scored better on their test. And so based on the mean, Miss Kitts' class scored highest because they had the highest mean. So the mean you could think of as a balancing point. So a balancing point meaning that if I were to put this point on the data, it would be even. So let's look at these two dot plots like we saw back in 10.2. Both of these have a mean of 5 because there's where they balance out. If I were to make that a scale, they would sit flat because they'd be the same on the left and right. However, this graph on the left has a distance from a distance of 5 is 0 because all the points are stacked right on top of 5. They don't have a distance from the mean. Versus the distance above the mean in this one, I've got a +2 above the mean, and then the distance below the mean, I've got a -2. And so while the mean is a good picture, it also doesn't give us the full picture. Both of these data sets have a mean of 5, but they look very different. This data point on the left, these are all 5. It's the set is 5, 5, 5, 5, 5, 5, 5, versus this one does have a little bit variation. So that's why we're going to need more than just the mean. But before we look at that, let's look at two examples to do with mean. So the first one says the mean time for a 5K run with 10 runners was 20.15 minutes. If 3 more runners whose times were 23.2, 20.5, and 24 were recorded, what is the new mean? So what I have is I had a race and just 10 runners had an average of 20.15. Well, then 3 more people, I added in their averages for whatever reason. And now I've got runners whose times were 23.2, 20.5, and 24 minutes. So first off, the question says, should my new mean be higher or lower than my old mean? Well, the new mean should be higher because I'm adding in numbers that are larger than the prior mean. So here was my mean. And then I'm adding in 23 minutes, 20 minutes, and then 24 minutes. So that number should go up a little bit. The question specifically asked for, if 3 more runners whose times were this recorded, what is the new mean? All right, so the first thing I have this old times. The times that I highlighted up here in yellow. Now that old mean was 20.15, but there were 10 runners. So I have to multiply that 20.15 by 10, and then I can add in the new times. And so then I'm going to add in the 23.2, the 20.5, and the 24 of my new times. And then divided by the total. Well, from the old times, I had 10, and then I added in 3 more times, so now I have a total of 13 on the bottom. All right, I need to do this numerator first, so I'm going to multiply 20.15 times 10, and then add those other 3 times. When you do that, you get a new numerator of 269.2. And then 10 plus 3 is going to give me 13. And then when you divide those, we get a new average of 20.7 minutes, which is what I expected. I expected that new average to go up a little bit because I added in some slower times, some higher times. All right, the next one says the mean score of 10 students on your first test is 85. The mean score of the other 5 students is 97. What is the mean score of your whole class? And so I've got 2 different groups. I've got these 10 students who scored 85. And then I've got these 5 students who scored 97. And so I've got 10 students who scored an 85 plus the 5 students who scored a 97 all over the total. I've got the 10 students from the first group plus the 5 students from the second group. And so when I add up that numerator, I've got 1,335 on top, 15 on the bottom. Divide that, and the average of my whole class is going to be 89%. So the big thing with this is you have to do these weighted averages because 10 students are averaging to 85. I have to multiply those two. And because 5 students are averaging to 97, I have to multiply the number of students times their mean.